Good day, student. Okay, now let's continue with another chapter of probability. This chapter is called further probability. It's an extension of the easy question from probability. And this question, always one question in paper 4, in extended paper. Okay, now let's learn a few probability terms first, which is maybe you came across but you don't know what is going on. Let's see number first. You always see something in a question say equally likely outcomes. The meaning of this is the outcomes are equally likely means they have the same probability of occurring. That means they appear with the same probability, no bias. This is called equally likely outcomes. Just like when you flip a coin, the chances to get a head and tail, they are equal. It is not biased. Okay. So another one will be mutually exclusive event. What does that mean by mutually exclusive event? When the two events are said to be mutually exclusive, that means they cannot happen at the same time. Just like when you flip a coin, you either get tail or head on it. You cannot have in the middle. That means we not count that one as our outcomes. We only need either tail or head. So that is called mutually exclusive. That means when you get head, you cannot get tail. When you get tail, you cannot get head. That is called mutually exclusive events. Or you can roll a dice, and when you roll a die, you get odd and even. They are not, and they cannot happen at the same time. Right? All right. Okay. Next one, independence event. An event means like a throw or how to say. An event is like an experiment. The experiment is called independence when the result of the second event is not affected by the first one. Just like when you flip a coin, the first time you flip head, the second time you flip head, there has no connection at all. It's just by chance. So then when the two events are called independence, that means the probability when you want to be like the first time you get head, the second time you also want to get head, the chances is the first time, the probability of the first time, you need to multiply the chances of the second time. If you want to get both head, like A and B means you want to get head and head means the chances is half times half. That is the meaning. Okay, for example, this one. A box contains 4 red marble, 4 red, 3 green, 2 blues. So one marble is removed from the when pick up from the box and then replace it back. After you pick up, you see the color, then you put it back. Then another one is draw from the second one, the same box. That means you need to draw 2 times. When you need to draw 2 times, the probability of the first marble has nothing to do with the second one. You can see from here. So let's say the question is asking what is the probability that the first marble must be blue, the second one must be green. So because you replace it back, so the sample space, that means you have 9 here, 4 plus 3 plus 2, you get 9. The total as 9 has it didn't reduce. It's still you still have 9 after you put it back the marble, right? So that means if you want to get blue, then green, that means the first time must be blue. So your chances is 2 out of 9, right? 2 out of 9. And the second time you want to get green, so your chance will be 3 out of 9. 3 out of 9. Right? So that means after because you want the first time blue, the second one must be green. So the chance will be like this, 2 over 9 times 3 over 9. So you get this, then you simplify, become 2 over 27. All right, this is called independent events. Because we're putting the marble back, so that means you didn't disturb the total. Okay. Okay, let's see. Another one is called dependence event. Dependence event means when the two events are independent, that means the second time will be the probability of the second time. You draw you whatever you do whatever. The probability will change because of the first time. All right. Let's see the same example just now. For this example, we still have the same marble, 4 red, 3 green and 2 blues. Then after you pick out one, you see the color, but you're not putting it back to the whole box here. That means if you do not put back, that means you already affect the total, right? Because you already make reduce the marble one of them. So that's why if the first marble is not replaced, the sample space of the second event has reduced one. That means you only have 8 marbles right now. So if let's say the probability is asking, I still want blue, then green. So the first time when you pick up blue, the chance is 2 out of 9, right? Correct, right? Then because after that we don't put it. Let's say the marble that you you pick up is blue, so you don't put it back anymore. So the total now becomes 8. The total becomes that. But then because the first time is blue, it's not, so you still have green marble in that bag. So you still have 3, but then out of 8 right now. So you can see from here, the second time, the possibility here change, the total change, the number already changed. So what you do, you just have to multiply it again, then you get the answer. You can see the answer is different from the first time. That one with replaced one. So that's why when the 2 events are dependent, that means the second time, the chance, the probability here already affected by the first time event. That's why we call it dependence event. All right. Next one. Another one is called conditional probability. Conditional probability is a measure of the probability of an event occurring given that another event has occurred. That means it's similar like a dependence event, but then this one a bit different. You see what is the example here later. The condition probability of the event is probability that that the event will occur during the knowledge of the event have already occurred. That means let's say the probability is written as PA. This is a how to say, a line, a vertical line, then followed by B. The notation of the probability given. This is what we call as the probability A given B. That means you already know the V happened already. Then only you want to find the probability of A. So what is it? The notation is like this. But then this thing you don't need to memorize so much. This is just something. How do we calculate it? Actually, we use logic thinking that you know what is going on. Let's see the example. Okay, let's say in a card game, supposedly a player needs to draw 2 cards from the same suit in order to win. You have 52 cards, right? The playing cards, the poker card. Then after that, one suit you have 13 cards in each one. Let's say the heart shape, you have 13 of them. You have 13 spade, you have 13 diamond, and so on. So supposedly the probability is like that. I want to supposedly the first player, player draw a heart already. So in order to win, of course, you need another second heart, right? The card, because they want two cards with the same picture to win. So if let's say you draw a heart already, so that means the second card you also need a heart so that you can win. The question is now, what is the probability getting a heart in the second draw? Right? That means what is the probability getting a heart in the second draw? So that means you can see the first heart is already been chosen. That means we know already it has been chosen. That means the card is heart already. That means we know the event of the B already. We know the event of B. That means it's already one heart. So next thing is I want to know the probability of A. A means I want to know another heart. I want to know the probability of getting another heart. That means B is the event that you know. You already got one heart in hand. You need a second heart to win, right? So the probability of A now given B means then that means this is how we count. You draw the first, the first card is already a heart. You need the probability of the second also a heart. So because you have one card of heart in hand already, right? That means you did not put in, you did not put in the deck anymore. So you can see the answer now is become 51. I mean the total cards inside the deck is is 51 right now. But then because one heart is in the hand already, so it's no more 13, it becomes 12 only. So that means the probability getting another heart for the second time will be 12 over 51. So this is the answer. It's different from just now. This is a conditional probability, means we already know one event first, then after that only we need to know the probability of the second event. All right, so this is one of the example. Okay, now next one is called tree diagram. This tree diagram is a way of showing a combination two or more event in the probability. This is very useful. Okay, each branch is labeled with the end of this outcome, and the probability is written alongside the line. Let's see. I'm rolling a die twice. That means you need to roll two times. One time, the second time. You can see how they put the probability in this tree diagram, so that we can easily identify what is the outcome. So the question is like that. I only focus on I want to get 6. So either you get 6 or not getting a 6. So the chances to get a 6 is 1 over 6. So this one here is called the probability of getting a 6. 6 is the outcome here. This is not a 6. So this is the outcome. And then this one is the probability. This one is the probability. So this is the first row. This is the first row. Look at this. This part is the first row. You have two branch here. That means I only need to know either 6, not 6. You can have more branches. Let's say if you want to get more selection, it's okay one. But now in this case, we only need two choices, either 6 or not 6. So you write the possibility here, the probability right here. Then this is the first row. Then after that, we continue each branch here, another 2. Either 6 or not 6. Even here, also you need to draw another one, either 6 or not 6. So the possibility here, the probability here never change. It's still 1 over 6 and 5 over 6, 1 over 6 and 5 over 6. You notice this, because we only need to know two events, either 6 or not 6. That means we only need to know two outcomes, sorry. Okay, either 6 or not 6. So that means our possibility, the probability is 1 over 6 and 5 over 6. So when you notice these two, when you add these two, you always get 1. 6 over 6 is equal to 1. So it's the same case here. 1 over 6 plus 5 over 6, you always get 1 here. You also get 1 here. So the outcomes can be, first time is 6. The second time also 6. You can see from here. These are the outcomes. You have four types of outcome, because we need to draw. We are rolling 2 times. So it can be 6, 6 for the first time, 6 or not 6, or not 6 first, and then 6 at the second time. So notice these two are not the same. In probability, the first time and the second time, the things when the things not the same, like this one, 6 and not 6, 6 not 6 and 6, these are two possibilities. These are two possibilities. It's not considered as one. They are not the same. Right? The first time is 6, the second time is not 6, or the not 6 and 6, they are not the same. Even though the total outcome can be, the combination is the same, but the sequence, the order is important. So the last one will be not 6 and not 6, not a 6 and not a 6. All right. So you can see this branch is actually helping us to get the final outcome for each category. I mean, each outcome we know from these three diagrams, then we can get the outcome easily like that. Right? We can read it very easy. And then let's see. Okay, there are 4 possibility outcome, right? There are 4 possible outcomes. That's like this. That's like what I said just now. And then we need to count the probability right now. Let's say in order to get 6 and 6, the possibility will be 1 over 6 multiply 1 over 6. Because we want 6. Look at the words, and 6. It's not all 6. 6 and 6. So that means the possibility, you need to multiply them, they get 1 over 36. Okay. Then if the first time is 6, the second time is not 6, that means you need to multiply the 1 over 6 times the 5 over 6, then you get 5 over 36. Okay. So it's the same thing to this one. Let's say the first time is not 6, so you get 5 over 6. And then after that, multiply the second time is 6. So you multiply this, you get also 5 over 36. All right. The last one will be not 6 and not a 6. So when both of them are not, that means you multiply the two possibility here, two probability here, then you get 25 over 36. Now this is what we call dependence possibility just now. The dependent no, independent event. These are two independent event because the first time you roll is nothing to do with the second time, right? All right. So these are all the answer of if I want to get 6 and 6. So this is the outcome, right? Okay, actually this tree diagram also can extend. It can have draw tree. That means you can draw more times. Then you draw the branch even more. That is how useful it is. Okay, then let's see one of the example from the textbook. Okay, in the winter, in winter, wait, sorry. Okay, in winter, the probability that it rains on any day, any one day is 5 over 6. That means we only consider rain or no rain. So they ask you to use a tree diagram to show the combination. So let's say this is day 1. Look at this. This whole thing here is day 1. Either rain or no rain. Because 5 over 7 is raining. That means 2 over 7 is not rain. No? So because these two must plus together must get 1. Remember, these two plus together must get 1. So if 5 over 7 is raining, so 2 over 7 is not raining. Okay. So then this is for the first day only. After that, the second day. The second day will be right here. Okay. If let's say the first time, you also have two types, either rain or no rain. So you can see the possibility is 5 over 7, 2 over 7. These two not change, and it's still the same. It's still the same. So then your outcome will be this: rain, 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 no rain, no rain, rain, no rain, no rain. All right. So it's the same like just now the dice. When you roll a dice, you multiply. Because this is not more 1 over 6. Because this one is given, so you must follow. That means 5 over 7 multiply 5 over 7, then you get this. Rain, no rain, these two times together to get this. No rain, rain, these two times together to get this. And no rain, you get this. So these four are the outcomes from this thing. Okay, so now we need to answer the question. The question saying asking you calculate the probability that it will rain on both days. That means the first day must rain, the second day also must be raining. So that means you need this. You need this branch, rain and rain. So when you need this, you get this. This is your answer. 5 over 7 times 5 over 7. And the answer will be 25 over 49. Okay, this rain and rain. So the question, okay, let's see the second question. Calculate the probability that it will rain on the first day, but not the second day. That means first day raining, the second day not raining. So you have to follow this branch. Here, rain, no rain. So the answer will be this, all right? 10 over 49. Okay, understand? Okay, I want you to notice the last question. Calculate the probability that it will rain on at least one day. Okay, look at this word. At least one day means it can be first day rain, the second day also rain. Because at least one day can be 2 days, right? Can be 2 days all raining. Okay, or it can be the first day raining, the second day not raining. Okay, it can be like that. That means everything we need here, these two answer we already need. We need these two already because we need rain, rain, and rain, no rain. And we also can first day no rain, but second day rain. As long as one day is raining. Okay, so that means we can also choose this branch. So that means we also need this possibility. So when you have these three, you need to plus them together. That means 25 over these three. 25 over 49, 10 over 49, and plus 10 over 49. Then only this is your answer. Okay, because we want at least one day is raining. Another way is you can think of we don't want both day no rain. Right? Because we only consider 2 days. So at least one day is raining. That means we don't want both days no raining. Right? We don't want it. So you can use 1 to minus the one both day not raining. Then you also get 45 over 49. It's the same answer of this. So this is another way of calculating this kind of figure, this question, right? Okay, next one, let's see another example. Okay, this one we do it together. Okay, it's still about raining. The probability that it rains today is 2/3. Okay, so now we only consider today, tomorrow. Okay, we only need to consider 2 days in a row. Today and tomorrow only. So if today raining is 2/3, that means this has to be 1/3. Later we need to answer all this later. Okay, if it rains, look at the question. If it rains today, then the probability that it will rain tomorrow, you see, become 3/4. So it changed already. It's normal following this one. You have to follow question. Now it's 3/4. So the second day, tomorrow is, if raining, that means it's 3/4. So then you need you still have rain and no rain as the outcome. Rain and no rain. Okay. Okay. Now look at this clue again. If it does not rain today, that means no rain today, and the probability that it will rain tomorrow is 1/6. So if the second day, the possibility to raining is 1/6 right now. So you write like that. Yeah. Okay. Actually, in this question, the diagram may be, they may ask you to draw this diagram. If not drawn by the question, you have to draw it yourself. But since it's already drawn there, I only ask for, okay, what is the fraction as the value of STU? Okay, so they ask for the answer. So you can see if this is 2/3 here, the S has to be 1/3. And if this is 3/4, this one has to be 1/4, because these two add together must equal to 1, as I said. So 1/6 is for this one, that means U has to be 5/6. So this is our first answer. You can see 1/3, 1/4, and 5/6. You need this later on. Now, the question 2, calculate the probability that it rains on both days. Okay, if not raining for both days, that means these 2 times together, 2/3 times 3/4. Okay, then you get half. 2/3 times 3/4, then you get the answer. Okay, you can leave your answer without simplifying, also can. But I would suggest you to put your answer in fraction. Don't put in decimal or percentage. Write your answer in fraction, easier to see. Then the third one, calculate the probability that it will not rain tomorrow. So it will not rain tomorrow. That means today can rain and no rain. Either one only, because it can be rain. It says, I want to know it will no rain tomorrow. So you don't care about today. Today raining also can, no raining also can. So you must know, you need to plus them later on. So the answer is, if raining, but not raining tomorrow. So you need to time 2/3 with T. T is 1/4. That's why you get this. And then you need to plus, if no rain today and no rain tomorrow also. So it's 1/3 S times U. So the final answer is this 4/9. Okay? This is how we answer the question. Okay, now look at the question B. Okay, question B has nothing to do with the raining anymore. Look at this. Each time Christina throw a ball at a target, the probability that hits the target is 1/3. That means if he hits a target, the chance is 1/3. So she throw 3 balls. She throw the ball 3 times. She throw the ball 3 times. Yeah, find the probability that that she hits the target 3 times. That means the first time also hit, the second time also hit, the third time also hit. So basically, we need to multiply all 1/3 3 times. You can see 1/3 times 1/3. This is second event, first event, second event, third event. So you can see you can do that. So the answer is this one. Okay. Okay. Now the question now say at least once. Okay. At least one means I can hit the first time, the second time, the third time also can. Or I can, at least one means a lot, right? You can have first time not hit, but second time hit, the third time hit also can. So you have a lot of possibility if we want to list it out a lot. So you can see, I don't want to use this method. If they say the question said at least once, that means I just don't want never hit, right? So I will use 1 to minus the one never hit. Okay, so I'll use 1 to calculate never hit. So 2 over 3 is never hit. If that means 3 times in a row, never hit the target. So 2 over 3, 2 over 3, 2 over 3. I just don't want this. Right? If I don't want this, that means at least one time I hit the target, right? So I will use this method easier. 1 minus this, then you get this as our answer. Easier, huh? Okay. Okay, now look at C. C, another guy is playing this thing. But the chances, the probability that he hits a target is 1 over 4 is different already. So he throws the ball until he hits a target. So it doesn't matter how many times. I just want to hit the target. So find the probability that he first hit the target with his fourth throw. That means first time never hit. Second time also never hit. Third time also never hit. Only the fourth time he hits a target. All right. So basically, you have four. That guy is throwing 4 times now. Okay. So that means the first time is not hitting. Right. The first time not hitting is 3 over 4. No? 3 over 4, you need to power 3 because 3 times never hit. Then the last time only you hit. So that's why it's multiply 1 over 4 for the last time. Right. So this power 3 means he throw 3 times never hit, but the 4th time he hits. So the answer is this. So you multiply this, you get this as answer. Okay. Now the last part, the hard question. The question asks, find the probability that he first hit the target with his end throw. Okay, now look at the first answer first. If he hits only at the fourth throw, he hits the target only at the 4th throw. You can see we power 3 to this thing, and then the final one is 1 over 4. This is the probability that he hits the target. Okay, you can see this is for 4 times, right? This answer is for the 4th throw. That means this is 3. Right? Why is it 3? Because 3 times never hit. Okay, so if now is n throw, I want to know the answer in n term, in n, something to do with n. So that means this one has to be n minus 1. You understand? Because you need four throw to win, right? To hit the target. This is the last throw. That means 3 times never hit. So that means 4 minus 1. 4 minus 1. That's why you get 3. You get 3 here. So to answer this question, n throw, the answer will be this thing. 3 over 4 never hit, n minus 1. N minus 1. Then you times 1 over 4, which is the time that you hit. Right? This is for it. So that means, let's say this is 6 now, 6 throw now. So that one will be 5. This part will be 5. And then the last time, that means 5 times you never hit. The last time only you hit. Okay. So this is the answer for the last question. Okay. Okay. Now the probability question also involve set. Look at this question. This one will more like conditional probability. It's actually very easy also. You look at this question. In this Venn diagram, each of this is called a number. Is the element number 1, 3, 5, and so on. Right? So it's already categorized. It says all is odd number. All these are odd numbers, and P are the prime number, and the rest are not belongs to these two. So that just put it outside. You understand the set, right? Okay. Now the question say a number is chosen at random. Calculate the probability that it is a prime. So if the question is asking for prime number, right? So you have 15 here, I think. Yeah, 1 until 15, right? So 1 to 15. That means you have 15 element here. So the total is 15. And then how many prime number? 1, 2, 3, 4, 5, 6. You have 6 of them. So that means the probability in getting a prime number is 6 out of 15. All right, this is easy. Okay, now look at the third one. They say a number is also at random. Calculate the probability that its price given that it is odd. That means you already need it is an odd number from here. You only need to focus on the odd number here. Okay, so from this odd number, how many are from P? That is the question. That when you read this P probability, P actually is a straight line here. It's a vertical line. It's not like slash. If P given O, that means you already know it's from O. That means how many from O? 1, 2, 3, 4, 5, 6, 7, 8. You only have 8. From these 8 numbers, which one belongs to P, that is the question. So you already know the number is from odd. So therefore, the total number of the possible outcome is only 8 because you only the all right, all only has 8 here. Then you only need to know the from P. So that means P is here. 3, 5, 7. These five figures are from P. So it's 5 out of 8. So this is the answer. Okay. Very easy, right? Let's see another question. This answer is related to conditional probability also. Okay. Okay. The Venn diagram shows the types of vehicle owned by a group of 60 people. That means when this is no more a figure, this is the number of element. This is that means you have 12 members here, you have two elements inside here, you have 3 elements here, you have 1 element and so on. So C represent car, this is motorbike, and this is bicycle. Okay, so now let's answer the question. If a person pick at random, calculate the probability that you own the following vehicle types. PC. PC means probability. Those are from from car, so from the category cars. Yeah. So you calculate from here how many of them? 12, and plus this, and plus this. So you have 24, 29 of them. So that means it's 29 out of 60. Yeah? 29 out of 60. 29 out of 60 will be your answer. All right. Okay, let's see B. Yeah? B is probability M union B. M union B means I combine M and B. M and B. If I combine them, I plus this 1, 2, 3, 4, 5, 6. This 6 figure I plus together. So I get 48. 48 will over 60. So this will be your answer. Okay. And C intersect with B. C intersect with B means these two law, 12 and 3. When I plus this, you get 15. 15 out of 60 is your answer. Okay. All right. And then D. Okay, look at D. D means the probability of B given C. That means I only need to focus on the category C here. And then from this category C, which one belongs to B also? Okay, so that means you only have these two. These two belongs to B also inside C. So you have 15 out of the total of C only. Don't care about 60% now because we only consider C. Then from C, only 15 is also belongs to B. So that will be 15 out of 29 because when you plus the C is 12, 24 plus this is 29. So the total is now only 29. Okay. And now C given B. C given B means I only focus on B. C only focus on B. And then I want to know which one are from C also. You have 15 also, but out of this total. So it will be 15 out of 42 because here only 42 here, only 32 here. Okay, then look at this. C intersect with M given B. So we also focus on B, and then I want to know the one C intersect with M. Right? From here, C intersect with M is only 3 here. Actually 2 and 3 but then because we only consider inside B, so the answer is only 3 here. 3 is belongs to C intersect with M. So that means 3 out of 42 here. Right? 3 out of 42. Okay. And now G, P probability M slash C complement. C complement means we don't want C. We don't want C. So we only have these 3 now. So you have 31 here, 26 plus 4 plus 1. Then the question I'm asking, it says also belongs to M. That means out of these 3, which one belongs to M? This one or these 2? These 2 will belongs to M. So you have 5 out of 31. Okay. And then the last one will be M complement given B. So we focus on B and then we don't want M, right? See, if you focus on B, don't want M, that means you have these 2 here. The B, inside B, which one not belongs to M. So you have these 2. So you have 38 because 26 plus 12, you get 38 out of the total here, 42. Okay. So this is basically how we answer this kind of conditional probability question. B is the mother. You only need to know the outcomes of this one, right? So I want the one, I'm considering the B now, but I don't want the from M. So you have these 2 are out of the total of B. Okay, so basically that's it for this for the probability. Then you have exercise to do. If you are hardworking, then you can do page 496, student assessment one. I don't want you to do the exercise from the book. Okay, so much, don't waste your time. You focus on student assessment one, and I also will attach one past year question, which I compile already. Then you can continue to do it. Okay, I will pause the answer after some other day. All right. Okay. Thank you.